for recording. Yeah, sure. Okay, I will introduce myself together with the slide. So let me just share first.
Okay.
How can I share screen?
You should see like a square with an arrow on the top. Yes.
Is it working?
Yes, you're doing it right now.
Okay, nice. Okay. So everyone sees the presentation page, right? Okay, cool. So hi, I'm Yen-Chia, and nice to meet you all. It's very nice to join this working group. So I was working with air quality issues for a long time, but primarily in the US context. And it's very nice to see like there's also a group of people who are working on citizen science air quality issues in Europe. So today I'm going to explain my projects primarily done in the US. I work in the US for a long time, including my master's degree, my PhD degree, and then work as a postdoc for 1.5 years. I spent about 10 years in the US in Pittsburgh area. And I work a lot with the local communities in addressing air pollution, air quality issues specifically. So I often work with local groups, like the picture that you saw on the image, that's one of the group meetings that we have in the local region. So I often walk into communities, talk with people, and then collect data with people. And today I'm going to talk about the topic of empowering local communities using AI, specifically focused on the AI applications. Okay, let's start. Some story about me. I'm currently a postdoc researcher in TU Delft in Netherlands, and I started my career from Taiwan. So I was born in Taiwan, and originally I got my bachelor degree in architecture department because I was trained to be an architect. And then in the second year, I began to be very interested in the computer science field. So I also double major in computer science. Then I moved to the Carnegie Mellon University in the US. I get my PhD in the Robotics Institute and also do my postdoc there. So I study human-computer interaction techniques, machine learning, computer vision, and I also work a lot with local people and eventually get really very interested in the citizen science area, especially in urban air quality issues. So over this presentation, I will talk about several projects that I did with the local communities on urban air quality. And then now I just moved to TU Delft this March, and I'm working on human-centered AI or human-centric AI approaches to build systems to engage people in large-scale conversations, for example, like COVID-19 issues. Okay, so this is a brief summary about what I'm doing for my research. I use citizen science and technology to empower local people, specifically on environmental and societal concerns. And one example in my case is air quality. So let me just give you an illustration about that. We have local people who need help, maybe, and a lot of time they really need help in collecting data and evidence of air pollution. So this is what happened in Pittsburgh. There are people who suffer from air pollution issues for decades. And then we have the scientists typically in the universities. They want to study the impact of air quality on local people, which is like me, in the university researcher, want to study and work with people in addressing air quality issues. There could be policymakers who want to engage citizens in air quality policymaking. And I'm specifically interested in the collaboration mode between them. So these multi-stakeholder environment, how can we use technology and how can we build AI systems together with different stakeholders? Okay, so in this presentation, I will cover the basic concept of using AI to empower citizens. And I will briefly cover a broad picture about 3 interactive systems that I built over 10 years. And I'm going to conclude with some visions and future directions. So what exactly does it mean by using AI to empower people? So this means it's actually somehow related to the citizen science area. And citizen science, it's like area that I define it as the collaboration, multiple collaboration between different stakeholders. And current research I found typically investigates how scientists can design AI systems for citizens to participate in research at a large scale. So in this mode, here's an illustration. Here's the scientist and here's the citizens. So it's often in this direction, which means the scientists define research questions and citizens are participate in some projects that are well defined by scientists. For example, this one is called Planet. It's a mobile application that people can take, and then they can take pictures of flowers, and then the images that they uploaded can somehow help the researchers to train a computer vision model for classifying plant species. So computer vision is a technique for computers to automatically read images or read videos, and then they can do some prediction task. Like in this case, it can predict which type of flower is this. So this is one example. And as you can see, this problem is defined by the scientists who are interested in studying biodiversity. But in my research, it's different. So I'm investigating how scientists co-design AI systems with local communities to influence a particular geographic region. So I'm inspecting problems that are really locally oriented, like air pollution. They can be different problems, different power relationships between people in different local contexts. I'm also emphasizing the idea of design with people. So that means we are iteratively design the solutions with the local people who are impacted by the problem the most. And I frame this as the field of community citizen science, which I work a lot doing my PhD in framing the entire field. So the idea is, here's the scientists and local citizens, but we are inverting this direction. So this means we are engaging citizens, but we actively participate in solving the concerns raised by the citizens. So in this case, the research questions, they are defined by the citizens, and they are somehow related closely to the local context. So for this framework, I write a paper to the communications of the ACM. Hopefully, I want to convince more readers or more researchers in the computing field to emphasize this and to raise the awareness of the need to design the system with people. So my research is in the intersection of human-computer interaction, which is an area in the computing research, and then AI, and also citizen science. And in here, in the community citizen science framework, I emphasizes a lot on the bottom-up approach of participatory democracy. That means working actively with people and solving local concerns, and have people be actively involved in the research also. And I also emphasize a lot on co-designing systems with communities to collect local community data. Okay, so let me get into the systems I built. This is the first one that I was working with the local people since 2013. This is like a project probably 8 or 9 years before, and it's a system that I work with people in integrating multiple types of data to understand the local air pollution problems. So in here, we integrate videos, we integrate sensors, and we integrate smell reports, which I will explain later. And if you are interested, it's published in it's published in ACM. It's a conference called CHI. It's a human-computer interaction field. So here's the background of the problem. So this is an area in Pittsburgh. The green region indicates a community that suffers for air pollution for a long time. There's about 80,000 people in this community. The red area indicates a pollution source, which is a petroleum coke refinery in the local region. So it's refining coal into petroleum coke, which is one of the fuel to refine steel. And then during the process of refining, there's a lot of emissions that somehow should be catched by the facility, but it emits to the air, and then causes health problems and causes pollution problems to the region. So the communities, they have been talking about this problem with the governments for a long time. But the problem is in the local area, unfortunately, the government is kind of at the opposite side with the citizens. So the government said, oh, there's no problem in this area, there's no health impact. And the citizens, they think they need some kind of evidence to convince the regulators that there's a problem. So they ask us for help. So we work with them together in deploying different sensors and different cameras in the local regions. So we put equipment in their houses, and then they provide the spaces for hosting all these equipment. And then eventually we hope we can design a solution together to collect evidence of air pollution. And we want to present these solutions and evidence to the government or news media. And then we want to raise the public awareness of air quality issues. So this is the system that we designed with people. On the bottom right, you see a user interface. It combines multiple types of data. So there's images, and it's actually a video. We have cameras pointing at factories for a long time. This is like 2 and 3 years of data. And then we have a server that streams all these images back into our database to store it. And then we build a user interface that allows people to look at what happened at that day. So in the image, you see there's a lot of pollutions coming out. And on the bottom left, you see like a time series chart, like a line chart showing the readings of pollutions. So these are particulate matter PM 2.5 pollutions, where we put all these sensors in communities. On the bottom right, you see a map. That's the map indicating like the wind directions and all the sensor readings. So communities, they actually now, when they have this system, they can point at this system and said, oh, look, there's some emissions coming out from the factory. And then there's PM 2.5 sensor readings is going up. And then the wind direction goes from the factory to the community. So all this evidence, when combined together, becomes very strong when they combine with personal stories and actually influences the attitude of regulators. So this system was not designed initially in this way. It's an iterative design process that we eventually come up with the communities together. So our team, and including me, we went to the communities, and then we present the system for many different times, work with people, and so they know how to use that. And then they also talk about their need with us. And then eventually we also develop a computer vision and AI algorithm that is able to look at the videos and then figure out which part has industrial smoke emissions. So this is important because the communities, they were asking us, oh, are there any ways that can speed up the process of finding these emissions? So we were thinking, oh, computers can help. So I was trying to develop an algorithm for doing that. So this is the picture that you saw at the beginning. This is actually a really important event. It's on 2015, where the communities, they bring a lot of people, and then also the environmental protection agency regulators, which is like the environmental agency in the US, and then also the health department people. And then also I was sitting in that room. I was sitting at the far left. And then people who stand on the stage, that's the community leader. And then during the meeting, we project all these pollutions that we found by using the AI algorithm in front of people. So everyone knows, oh, this is really a bad pollution problem. And communities, they use the system to tell the story about how air pollution impact their local region. So this actually changes the government's attitude. For decades, this is the first time that they acknowledge that there is a problem in the local region. and they publicly announced that. And then later on, they reopened the negotiations with the local factories. So to me, this is a very important thing because that's how I see technology can have a impact on local people. And this is also why I'm interested in going toward this direction of research. So let me show you what we showed to the regulators. So we found there's a lot of emissions that looks really bad at the beginning, and we show, oh, actually there's more and more. And then they are from different days and they are at different time. And these pollutions, they are definitely unacceptable because they are kind of, they are pretty bad and they are definitely exceeding the limit of the visual opacities that usually get regulated by the US government. And then there's actually more and more. So by showing this evidence, we put everyone on the same page, and then we enables communities to be able to use this data to convince the people that there's a problem in the local region. So a follow-up research based on the first one is called Smell Pittsburgh. This is a mobile application that we built to crowdsource and visualize pollution odors with the local people. This is a project that is going on for probably 5 years now. It was inspired by the previous project because there's a component in the system about collecting smell complaints. And at that time, when we were talking with community members, they usually describe smell as a really important indicator of pollution. Like they said at night, they have to close their window because they will smell a really strong sulfur or tar burning smell. And so we think, oh, maybe we should collect all these qualitative data to kind of complement all the sensor data, because sensor data tells how bad the air quality is, but does not tell the experience about how local people experiences air pollution. And this paper is published in Transactions of Interactive Intelligence Systems, which is also in ACM. If you're interested, you can check this paper. The broad idea is the health department is collecting all this kind of data. So they have the website that collecting smell complaints, but in a way that has data quality and transparency problems. So they ask people to fill in information in text box. So that means when people go home, it's likely that they will forget what they are doing. And then it's likely they are going to forget the exact time and location. So they are going to enter probably the wrong data or some data that is not accurate. So that will cause problems in the further data analysis. And there's also transparency issues because when people enter all these smell complaints, it goes to somewhere that no one else knows because it's not visualized. And then so people don't really know if this is a problem in my neighbor or this is a problem in the city region. So we designed this system. It's an application. It can be downloaded on iOS and can be downloaded on Google Play stores. People can take it around and they can rate smell between 1 and 5. And they can also report the type of odor, like it's a rotten egg smell, or they can also report the symptoms, like if there's any eye, nose problems, irritations, and then we visualize all these reports in a map. So in this way, we collect accurate time information, we collect accurate location information, and then we show if the problem is at a wide scale or at a local scale. So citizens, they will be able to see their contributions, their reports on the map, like the triangle icons on the right indicates the smell reports. The color indicates how bad the rating is, like dark red means really bad. The circle icon indicates the pollution monitoring sensors. So these are the air quality sensors operated by the local health department. The blue arrow indicates the wind direction. So they can animate the map and then they can see it. So if you are interested, I have a link at the end, which I will show you. You can go to the website and you can explore all these visualizations. But unfortunately, all these the app only works in the US region. It doesn't work in the European region yet. So I have to kind of go to the US store to be able to download the application. So it was pretty US focused applications at that time. And after that, we began to be interested in wondering, how communities are going to use this data. So we have been collecting the smell reports for a long time, and typically around about 6,000 users per year, 6,000 unique users who are using our system. About 20% of them are pretty active, which is about 1,000 something users. And each year they contribute about 15,000 to 20,000 smell reports. So communities, they print all these reports in a giant scroll, and then they actually go into the meetings with the regulators, and that they read every single report submitted by the citizens. So in this way, they show how bad the air quality problem is in the city region, affects like thousands of people. So this actually influences the attitude of regulators, and then now they said they need to, and they will work on a more strict rules and standards for the petroleum coke plant. And then after that, we begin to wonder, actually, can we use this data to predict local air pollution patterns and identify the local air pollution patterns? So we built something which is like a weather prediction algorithm, which in this case is a smell event prediction algorithm that if we end up predicting something, then we send a push notification to our mobile phones, to our user. So the users get alert and they know, oh, in the next few hours, there's going to be problems in the local region. So they can plan ahead of time. Like they can plan their daily activities, or they can go out and then check if this is true. And our goal is we want to also inform the users and also increase user engagement. So here's how we do it. We use an AI model. In this case, it's a random forest model. So this is kind of a technical term, but in here you can treat it as a function that it takes some input and it produces some output. And its primary goal is to predict the smell events from air quality data. So here is how it works. So we take a lot of observations from the sensor monitoring stations. So these are the sulfur dioxide readings, hydrogen sulfide readings, wind speed, wind direction, or the pollutions, and then we put them all together into the model. And then the output is we predict if there's a smell event in the future or not. By looking at the current data that we have or the previous data that we have, we can train a model to do this kind of prediction. So we can predict whether in the next few hours, there will be a lot of smell events, like a lot of people will report smell, or there will be no events. And we also try to understand what's happening in this data. So we want to not just predict the events, but we want to know what happened in the local region. So I built a pipeline, which is a machine learning based pipeline. The details is in the paper, but now I'm just going to provide overview. So our pipeline is able to explain about 30% of our data. And then let me explain what's the data. So it's the joint effect of wind direction, wind speed, and also the hydrogen sulfide. So 30% of the data can be explained this way. When the source emits something, hydrogen sulfide, it's got picked up by the sensors. And then when the wind in the Pittsburgh region forms a certain pattern, then in the next few hours, there will be a lot of smell reports coming up. So in this way, I am using a model which is called a decision tree model. So there's some complicated pipeline of selecting a subset, and I feed that into a model that is like a doctor explaining the diagnosis patient. So think about decision tree as a doctor. The first node or the first predictor that is looking is often the one that is the most important. And it turns out this factor is the interaction effect between the wind direction and the pollution sources emissions. So it sort of tell the local pollution patterns in this region, and it tells us, oh, there's a large collection of the problem or the smell reports, they come from this pattern. So in this way, I try to explain what happened in the local region, and the reason, the motivation that why I want to do this is because community members, they over time they were checking all these visualizations, and they found, oh, there's some kind of similar patterns in the data, and they are asking us as a researcher, like, how often did you see this? Can you actually quantify and explain it in a way scientifically to us that is this a dominant pattern in the local region? So that's why I begin to inspect more into this problem. And the next one is after we build this model, we use the push notifications to engage people, but how effective is that? So I want to know it. So I run a regression analysis to show and then to analyze if sending all these push notifications actually increases the user engagement. So here's how I do that. The first case is in the real world, there is some problem. The algorithm detects the problem and sends a notification to users. That's the first case. The second case is there is some bad problems in the real world, but the algorithm failed to detect these smell events. So users didn't get anything. So we have these two scenarios, and then we feed that into a regression model, and then we do some analysis to show if there's a positive correlational effect in that. So it's a complicated model. It's called generalized linear models. But in here, I'm using a visualization to explain that. So on the x-axis, it's the treatment. Treatment means whether we send the notifications or not. Regress by the confounders. So the confounders are for example, the air pollutions, air quality index of that day, and then it could be also like time of the day or something. Basically, there are any confounders that can affect both the treatment and the outcome. On the y-axis, we use the prediction. We use the like the user engagement metrics, which in this case, I'm using the number of page views in the system. That means how many people actually look at our system and check the visualization. On the y-axis is this predictive, this metric regressed by the confounders. So in this way, we can get rid of the effect of confounders, and we can look at the true relationship between the treatment and the outcome. So in this case, you see there's a positive relationship between these two. So that means they have somehow some effect. So that means in our case, we actually found sending push notifications out can actually increases user engagement. Okay, and then the next project, the final project that I'm going to talk about is called the Project Rise. It's a continuous project based on the first one, where I mentioned there's a computer vision algorithm that is looking at one specific region and output a prediction about whether there's a smell or not, whether there's smoke, industrial smoke or not. So the problem in the first project is the algorithm that I was building. It's a heuristic-based approach that is really specific to one camera. But now I want to build a more generalizable solution that can work on multiple cameras. This technique is called deep learning, which is a deep neural net. It's a technical term, but just think about it as some complicated functions that is able to build a model that is more generalizable once we feed enough data into this model. So the first challenge that I come up is there is no such kind of data set in the literature that allows me to train a computer vision model that is able to automatically identify if there's a smell or if there's smoke or not. So we end up have to collect the data set by ourselves. And in this case, we collect with local communities about 12,500 video clips where we labeled as yes or no. That means this video clip has smoke emissions, or this video clip does not have smoke emissions. And the average number of video frames per video clip is like 36. And then we have about 19 different views. That means we have 19 different videos pointing at different locations. In this one on the right, you see different views. And then here's how we do it. We deploy many different cameras in multiple locations. On the bottom left, you see a camera. So that's the camera that we build is a commercial camera that we put into a system, and we use a control board called Raspberry Pi to kind of build that together with the camera, so it can automatically take pictures every 5 to 10 minutes and stream the data back to our server. On the right, you see several video clips. That's the video produced by the system. Some of the video has smoke. Some of them are smoke mixed with steam. Some of them has only steam. So it turns out this is not an easy task for people to label. So we over time, we build a labeling system. So I built a system that shows people several videos at one time, and I ask people to go and then label whether this video clip has smoke or not. This system is still alive. It's still like online, and then people can still use that to label all these images. And then we also have the trained AI algorithm to run predictions and then show people a bunch of collection of bad smoke events. So just give you an idea, this is some technical details. We use deep neural net to predict this. Let me give you a visualization about that. So this is how the neural net is looking, or the AI model is looking at the video clips. So this is from the left to right, that's the video clip and separated by image frames. So it turns out the model, when we visualize which area that is looking at, it's actually looking at the area that has smoke. So it's not looking at random stuff that is like steam or something. So it's a way that we try to validate if the model is learning something useful. And in this case, our performance can reach to F-score 0.82. So this is a combination of precision and recall. It's a metric that we use to evaluate the model. So precision means if we say yes, so every time we predict there's a smoke event, how likely is this going to be true? So every time if we say yes, how accurate is that? That's called precision. So in this case, we can reach up to 0.86. Precision and recall, they are all in the range between 0 and 1. Recall indicates how many events that we catch. So if recall is pretty high, that means we catch everything. If recall is low, that means we miss some events. And then the F-score is just a simple metric to aggregate all this precision and recall together. So as a baseline to compare, if we always say there's a problem, that our precision is going to be really low. It's 0.41 because there's only 41% of the chance that this is correct. But the recall is going to be 1 because we basically say yes to every event. That means we catch everything. And the F-score is going to be bad because it's a combination between them. So that's like the basic idea about how we evaluate the model. Okay, so these are the 3 systems, and let me talk to you about the future visions. This is how I imagine the community citizen science and AI direction could go. The first thing is I think community citizen science can be a field that connects the computing research or to really deeply grounded research to practice to impact. So people can build systems and then build some projects to work with local citizens, and then we deploy that and evaluate the impact, and then we do research, and then it forms a cycle. So that's something that I imagine as a vision. And it turns out there's several challenges in this area, which I am working on framing this problem. It has been submitted to a journal, but it's not published yet. It's only exists as a preprint. Let me explain all these challenges to you. The first challenge is in the co-design of systems with local people. So during the time when I was working on designing system with local people, I was doing research about different design methods. And what I found is many co-design methods, they are not centered on citizens. They are centered on helping researchers understand problem, but they are not centered on citizens to help them. So this is a problem that I believe we need somehow a new research method or adapting the current research method that can be centered more on citizens. The second thing is, when I come to the community, I feel like there is a huge knowledge gap between me and the local people. Because these data, they are community data. They are not like the general image classification task that is something like categorizing cat and dogs. They are specifically related to the local context. So that means there are a lot of local knowledge that is required to conducting this type of research, which means we need to unite the knowledge of local people and the researchers. And that's the hard part. The second challenge is in collecting, analyzing, and explaining all these kind of community data using some kind of AI pipelines. And the reason that we need to do that is because we need to provide data to convince people, and we need to kind of explain to people how are we going to use this. And the challenge is communities, they don't like the research procedure to have a formal statistical significance before the government can take some action. They want some immediate social impact that they can see. And this is a challenge because it's how can we show this kind of impact to people? It's not really easy. And it's also hard to develop such AI systems or pipelines because to know if the AI system works, we need to do some experiment formally. And the problem is, if we do experiment in communities, it could be non-ethical because that means we are controlling the information flow, because we are basically saying there's a group of people who are going to be excluded from this kind of tool or information. And there's another group of people who have access to this information, and this is not really fair to them. The third challenge is in the long-term engagement with citizens. So it's a chicken and egg problem. How are we going to convince citizens to contribute data when we don't have data to show them that this is effective? So this is some problems. Like initially, citizens does not trust the AI system because they don't really know what it's doing. They don't really know what's the capability of these AI systems. So they may be unwilling to contribute data. But we need this data to show them that this has an impact to the local region. So this kind of chicken and egg problem somehow need to be solved. Also, over the time when we deploy the AI systems, we need to adapt the systems to long-term changes in the local region. Like we may need to update the model, we may need to tune the model, and we may need to adjust the behavior of the system for long term. And it turns out this is challenging because there can be grant funding issues that maybe this is a one-shot funding grant. And after that, there's no resource to keep maintaining the software infrastructure. Okay, so I have explained the challenges. So what can we actually do to connect research together to all these citizen issues and citizen need? So I think the first thing that we can do is we can evaluate the AI system's social impact and frame it as an empirical contribution to the research community. So somehow we can produce research together while also work with citizens. Like in this case, this is actually one example. It's the way that we work with communities, and then over time we learn and we kind of frame the code design process, how we translate local knowledge into system features, and then we report this as empirical findings about how we work together with local citizens. And we observe and evaluate how people use the data produced by some AI system. And then we frame it as a contribution, as a case study. So this is published in the human-computer interaction research. So this is, I believe, is one viable research direction to go, empirical contributions and case studies. The second thing is believe we can evaluate AI interventions, and then we can study its impact on local regions. So for example, I study the impact of push notifications and I send to local people. So this is somehow also the same. It's an empirical finding and then some qualitative analysis about how AI systems can engage people in citizen science research. The third direction is, I believe, it can be a methodological pipeline that we can do a research on how we can build AI models or how we can build machine learning models to explain pollution patterns to people. So the current research trend is the explainable AI pipelines. They are primarily designed to help researchers, but not help lay people. So in this case, for example, one of the things that I built is something that I explained before. It's a system that is capable of identifying some patterns and then explain some patterns in the data so that the local people know what's going on and what's happening in the local region about air pollutions. So these methodologies, it can contribute to the scientific research literature. Like in this one, it's also a valid contribution that has been acknowledged by the journal. It's called methodological contributions. The fourth one, which is typically more AI related, it's the study of how we can co-create data set with local people while also empowering people. So one idea is in the last project, I work with local people in labeling all this data together. So this kind of research output can be framed as dataset contributions. These datasets can help other researchers build better AI models to recognize smoke emissions or also other different kinds of tasks. While also at the same time, when we work with local communities in labeling data, over time, they get confidence, they know what the AI system is doing. So they trust the AI systems more because they know how we build the AI system. They know they contribute the data. They know the output is kind of similar to what human is doing, is trying to look at the video and try to analyze, try to figure out if there's smoke. So this has benefit to long-term engagement. So I just want to mention some acknowledgements. So typically all these projects, they were funded by local nonprofit organizations, which is called the Hans Endowment. And we also work with several air quality groups in the local Pittsburgh region. And if you are interested, you can play around with the system. It's the air quality monitoring system. These links are live. I can send this PowerPoint slides. I share this to you so you can kind of look around and see how these systems are working. They might be a little bit laggy because the servers are in the US. So when you download, when you're trying to access the videos, it could take some time. But general, that's all the presentation. And hopefully this is interesting, and I'm happy to take questions.
Thank you so much, Yen-Chia, for this really interesting presentation. And yeah, we have some time for questions. Kostas, please.
So really thanks. Very interesting presentation, has touched upon very many issues. I must admit that I very much appreciated the artificial intelligence part, as we have been working in this field also for quite a lot of time. Citizen engagement and empowering is one of the most hard nuts to tackle, let's say, to crack in citizen science. So, because you have been working with communities, do you think that let's say, this perception that initially you reported citizens have, they would like to receive some feedback very early, to receive some answers and to have some meaningful decisions affecting their everyday life. And this cannot happen usually. So how do you find that this can be addressed practically? How, so they are just patient, or you try to build upon, a confidence and a trust relationship between the researchers and the citizens, bypassing maybe, the relationship that local political structures are trying to establish. How do you do that?
So in the Pittsburgh region, the way that we do that is we work with a local group of people. It's a small group initially. It's probably about 5 people. They are really enthusiast people, and they are kind of like retired engineers, and some of them has backgrounds in all this knowledge, and some of them are tech savvy, so they know how to install sensors in their houses. So we work with these people, and over time we build trust between different people, and then they have influences in their communities. So we work with them to build several different prototypes to show them, how the data can be used and how you can analyze the data in this way, and then explain what we are doing. So it's really at the very ground level. So we are working with them directly. And then over time, like we go into their houses to meet with them, or we go into their area, and then sometimes they visit us in the campus. And then over time, they know how this thing works. And then when we release some kind of tools, then they talk to other people. They spread the message and they say, this is working. This is really good. And then we also go into communities to give presentations in some big events. Like usually monthly, there's an event organized by local people. Usually it's these core group of people in their house. There's probably like 40 to 50 local citizens. And it's the time that we kind of explain how this works, and then they endorse that. So we spread the message from a small core group and eventually reach out to more people.
Thanks. So you are using, let's say, something like local ambassadors.
Yeah, that's what I was saying.
The Trojan horse approach, which is working.
Yeah.
Marisa, you wanted to comment?
Yes, I actually, thank you very much. Really excellent work, very interesting. And probably it's the first time that I hear someone presenting so clearly also about involving people in quality monitoring using technology, and particularly this attempt of using AI. I was also saying something along Konstantinos, that you are using gatekeepers or champions, people within the community, because you are using this concept of community citizen science, if I remember correctly, which is, I noticed, a bit different from what other people in the citizen science field are using the term. Probably you are familiar with Karin Cooper, who is recently they have published something about the need to rebrand citizen science and use community citizen science. But they are talking about the need to be inclusive, because most of the citizens actually participating actively are white, well-educated. And actually what you just said reflects what she complains about, in the sense that you need to involve, you are actively involving those people who are usually the core participants in citizen science. You are talking about the well-educated engineers, people who know how to use the sensors. So because otherwise, so it means that without the help of those active people, you seem to be unable to reach out to the rest of the community. I understand correctly, Yen? Sorry, I'm not sure how to pronounce your name correctly, but it seems to me that you have a very lovely intention here, and it's necessary. But you see, in order to reach out to the community, you need to involve those people that we complain about, in the sense that they are usually the only ones or the main ones who contribute the most. Isn't it ironic a little bit?
Well, I think it's hard to actually directly engage with the marginalized communities. And according to my experiences, there are very complex politics, because the marginalized community, they don't want to participate. One example in Pittsburgh region is people who live near the factory, they don't want to see the factories down. They don't want to do this kind of research because their life is dependent on the factory, because they need someone to pay them salary, and that they don't have time to do all this work because they need to work for a living. And it's a really sad story that people did some, when we talked to people there, they said, I'd rather die slowly than having no salary to feed my family. So it's something that is challenging. And then over time, I found the people who have time to work on these issues, they are the privileged people because they don't have these money problems that they don't need to work on, that they are retired, and they have time to contribute to these projects. So it's an issue. Yeah, I know. And then absolutely. I don't really know how to solve that.
That's why the Greta Thunberg probably has forgotten a little bit about that. But thank you very much. It's really interesting what you're saying. Yes, thank you.
Yeah, it is. I will, because I think this also links very much with the presentation we had from Jean-Paul the other day. So maybe Jean-Paul, please go ahead and ask your comment.
Thank you, Nuria. I came in a little bit late, but I did capture the idea of your presentation, and it's very, very inspiring. I think in every city we just have that issue. Not only cities, also in rural environment, we have this issue of smell, and it's one of the most difficult things to really lay your hands on. And one of the beautiful things that you've done is using the best sensor that we have, which is our nose. And using also video material to actually visualize things and make things concrete, because also the difference between steam and smoke and those kind of things are sometimes very confusing for people who don't have any idea what's going on really and only react to the smell. My very first reaction is, how can you make everything that you've done, including the application on the telephone, available to us? If you hear a sound, or the people working in the apartment near here, this very disturbing. But anyway, so I would love to see if the development that you've done and all the work that you've done, can we use this, for instance, in our city? I think it should be relatively easy to adjust it. And I have plenty of environments, not only here in the Netherlands, but also in other places where we get involved, that we can really make use of all the efforts of yours.
All the code is open source, and everything is open source, all the code. And if there's funding, it's definitely possible to help some researchers or software engineers to port the system to the European area.
But is that also for the application on the telephone and that?
Oh, yes, they are all open source, yes.
Beautiful, wow, okay, we'll be in contact then.
Yes, we are reaching a little bit of time. Maybe just also some comment on the line of Jean-Paul. I also found the tools that you have created can be really useful, and in some communities here in the north, we do not have maybe so much problems with the industry. But we do have every winter also wood burning emissions from small chimneys all over the place. And a few days ago, this was this really inversion, and it was very cold. And even if the smoke was not near me, right, like this strong smell, and I could not take any path away of it, right? It was all over the place, right? And I thought these tools you've been created, have you also applied them besides industry to communities with that use wood burning or coal burning for heating? Have you?
Yeah, sorry, did I interrupt you?
No.
Oh, okay, so we did found wood smoke is one part in our data, because when I try to kind of investigate what's the common word that people usually bring up in the reports, a lot of wood smoke related keywords, but we didn't inspect more deep into that because primarily we were focusing on the industrial pollutions, but not the wood smoke. But we did see that coming up in our data.
it's really, really interesting application. Oh, thank you so much. Do we have maybe any last question before?
Nuria, a practical question. If Yen-Chia, is this the correct way to pronounce the name?
Yes, Yen-Chia, yes.
Yen-Chia, thank you. If you have 5 or 10 minutes more, then maybe if I would like to stay online, and if others would like to stay online and discuss, for instance, but is this technically possible, Nuria?
Yes, it is technically possible. I'm always a little bit like if we should do that or not, because the meetings are to last 1 hour, and people book that and then they go and conversations go out. But maybe we can have this democratic vote. Raise hands, the ones that think it's a good approach, and we can stay longer.
I cannot stay, but it's okay.
Okay.
Or I can open a new Zoom call.
No, that's not a problem. It can
okay.
stay. It can stay. I can leave it. It's just like then maybe I can leave this one and record the rest of the meeting, and then I just turn the recording off when.
Yeah. So maybe I think that the official recording can be off, and we can have a. This is an idea, or it's up to you. And whoever wants to stay online, I think that we can do it, because this is an opportunity we have. I have, for instance, half an hour maximum, to be honest, till the next meeting. I didn't plan for it, to be honest, also, but I'm very much interested in what you have been presenting, and I have already some things in mind that we can discuss.
Maybe. Yeah, I know, because maybe another option is also what we do, because I like to have always as much people and be as open to other. We can, because we don't have any plan for January on our meeting, and I will not have time to plan anything for January. That maybe because this is a topic and it touches so many things on the community level, engagement and the use of artificial intelligence.
Yes.
Shall we have a conversation on the first Friday of January, what is let me see, our next group meeting? It is happening on.
It's on the 7th of
It's on
December.
the 7th. Oh yeah.
I'm sorry, I'm taking vacations until.
But it will happen more on the, I think, 14th, because it's the beginning of the season. Like on the 14th, we can of January, we can restart again our talks. And I think this topic, then maybe also some of the colleagues that wanted to join today and couldn't join.
I think that this is a very good idea, Nuria. So the suggestion is, if I understand, which to have a theme, artificial intelligence, citizen science, and air pollution, which I would be glad also to contribute to the discussion with examples, project results, etc.
Yes.
So if we can plan this, I think that the 7th would be difficult because some people will be off anyway. But for the 14th.
Yes, so let's do that. I will
same time, so 11 o'clock Central European time, 12 o'clock for us, for instance, and 10 o'clock for UK. Okay.
Yes, let's do that, because also like some of our colleagues couldn't join us today. Let's do that, and then we have like 1 hour for discussion. Because
but again, I'm open if Yen-Chia, you are also available now. I'm open to stay a couple of minutes more and discuss technicalities and things like this.
Yes,
sure.
I will just then short the recording. Sorry, I will start the recording.